Under the hood, where the front battery box with two modules goes, on this back tray where the battery used to be, I've got 1, 2 riv nuts that I put in. And then for the front of the box, another piece of 3/4 leg by 1/8 inch thick aluminum. I welded a plate on the side. You can barely see it, a bolt here. I used one of the existing bolts over here. And then on this side, I did another riv nut and have the bolt in there. And I have 2 PEM studs in here for the box to mount on. So these riv nuts and PEM studs are really nice to have good solid threads. And they're quite easy to do without any tapping involved. You just got to drill the proper hole size. This was a simple bracket that I just had to cut and do a couple welds on the side, a couple dollars of steel. It's very strong support. The front box will weigh a little over 100 pounds, so this will be more than good enough. For the battery boxes, I bought some overstock ACM, that's aluminum composite material, from a building supply place. ACM is a 1/2 mil of aluminum and then 3 millimeters of plastic and then a 1/2 millimeter of aluminum. They're all bonded together. One side is nice and finished. They use this and they stick it up on the side of buildings. So this 4 mil thick ACM, like I said, is just as stiff as 3 mil thick solid aluminum. But because it's almost all plastic, it's lighter. This is 30 to 40% lighter than 1/8 inch thick aluminum. So many benefits to this. It's just as stiff, easy to work with, very cheap, electrically insulating, and lighter. You can also bend this material if you want to, if you need to put some bends in. I'll probably be utilizing this for brackets to mount other parts, and I might do some bends in them later. I got this for about $2 a square foot. So I bought a huge sheet. I was able to rip cut it with a normal wood saw blade on my battery powered circ saw, fit it in the car, and then I had some parts Waterjet. Here's the start of a mock-up of the front box. You can see there's a nice aluminum finish side here, also aluminum inside here. So I designed some boxes. I had them Waterjet, and then I had to countersink all these holes for my flatheads on a drill press. Super easy. I went with M5 by 10 millimeter long flatheads. M5 because that's the biggest where I could still have some diameter remaining at this end of the hole while still fully seating the flathead. And then if you can see, these are almost touching each other at 10 millimeters. So if I were to do this again, I would stagger the bottom and the top ones so that I don't have these contacting together potentially. That would just allow for more clearance with the screws and not having to worry about things like this because it's so close. I bent some 60 thou aluminum brackets, pressed in some PEM studs. Some PEM nuts. And so those are my corners, our flatheads just going straight into the PEM nuts. So all in all, this is really cheap. I also had I had these angles Waterjet also. I had the profile Waterjet and then the holes for the PEM studs. And I bent it up and just used an arbor press to press all these in place. So I'm very impressed with how sturdy this is. It's also nice that there's plastic in the middle because I have an insulating layer between the inside and outside. I guess you could argue that these bolt heads transfer it back, so maybe that's a moot point. A nice thing is I was just checking for continuity. I was checking between this bolt thread and the panel here, and there is no continuity. But if I go on the side where you can see exposed aluminum, there is continuity. So that's good. Something with the layer of this panel has some insulation properties where it's not conductive. So that's really good. I like that a lot. So maybe I do have that true isolation between inner and outer wall. And the only thing would be the bolts themselves, the bolt heads, because those are touching bare aluminum too. So it's transferring through the walls, but only the bolt heads themselves, not even this outer panel, are conducting. And one note to be careful with when water jetting these is you don't want to send the pressure too high. Here you can kind of see as they water jet this through hole here, it blew in between the aluminum and plastic material, and it actually blew out the sidewall here. So if you're going to do this, make sure you have the water speed rate turned down. They turned it down afterwards, and the rest looked pretty good and no blowouts. I mean, the flathead will keep this retained together, but it just doesn't look the greatest with that blowout bubble. This is incredibly low cost overall. Amp Revolt has boxes starting at $1,000 for 2, and then you add $300 per module that you want to stack. I'm at like $100 for a 2-module thing here, and then my 4-module is like $120, not much more. So if this works well, I think this is a really cool design and could be utilized by a lot of other people. But now I'm going to show a mock assembly of this front battery box. So the front box here, I have my 1, 2, this was a bad hole I shouldn't have drilled, but these go into the PEM nuts at the old battery tray. And then these two, I mount my flatheads onto this cross rail. The nice part about the flatheads is they're all countersunk, so none of them are above this surface. So now I'll go step by step to make sure that I can assemble my battery box. This would be done inside the hood. Even if I did have this fully assembled and could lift 120 pounds, the modules on the bottom would cover up my flathead mounting points, and I would never be able to mount it in there. I have these 3 sidewalls in because when this box is placed in here, the sides of this battery tray don't give me access to get to the screw heads that would be on these sides. So now I'm going to mock it up and make sure that I can assemble this. And then at the very end, I would have access to put the top and the front plate on. So first thing I put down is an insulating mica sheet. These came from the Model S battery pack. I bought these individually from the Tesla Parts Instagram. They're about $10 each. Next, I put down a layer of foam. This is actually cut up from an old yoga mat that I got for free. Most yoga mats are made out of PVC, so I was reading that at 60 degrees Celsius they start to off-gas. But that's not a concern for me because my charge controller is going to shut everything off at 45C anyways for the batteries. If the batteries got to 60C in here, have thermal runway, so I don't care. This PVC yoga mat's never going to get that hot. Not a concern. I just laid the first module in. My first issue is this bracket. I was hoping the coolant module would clear, but I actually had to bend it out so I could slide it in and clear this. It's not great to bend these. I didn't bend it a ton, but it can be bent back a little to get up and over there. I don't have my second one here because I still need to make that. But likewise, I can bend this one also. And so up front, there's clearance from the main points to here. I also have this heat shrinked. And here lies my design challenge. I have hardly any clearance all around here, mainly because of the constraints inside the car. I didn't want to go too long and prevent myself from being able to mount anything here. And I couldn't go too wide because the wider I got, the further I had to come out in this flare, which also meant the further I got forward here. So I was limited in width here. Also limited in height because the top of the battery box, as it comes across, the hood starts to slope down. So I've tested this and it barely clears, mainly due to the fact you can't quite see it here, but the hood itself has an arc. So it's about an inch taller in the center than it is along the side rails here. So because of all that, I have very tight clearances inside this box. I'm hoping this works. Next, I placed in one of the CAN data cables for the EVTV controller. That goes in right there. Then I went to put the next mica sheet on, and it interferes on the cable. So I'll have to trim this mica sheet a little bit. Next, I put in a series bus bar, connecting the positive to the negative. The main negative here, this is going to be the main negative of the pack. I'm not putting anything on. The EVTV controller main negative is where the current sensor should be. So I'm going to figure out if I can have a pass-through connector through this wall somehow, or if I'll just run a bus bar through and somehow isolate it from this wall. These are from Amp Revolt, usually $50 each. I got them scratch and dent, $25 each, which is awesome. This little bit of abrasion here is the scratch and dent. I don't care about that at all. This is inside a sealed battery box. But again, you can see how close my clearances are. This is covered in some sort of heat shrink, so is this. Barely have any space there. So I need to be very careful I'm not shorting modules into any of the walls here. Here's the second sheet of mica on. That's the notch I cut to clear the cable. Here's the second yoga mat. Muscle milk. Cut the same notch for the cable there. Got the second module in. Data plug going there. I'll have to figure out somehow to pass this through the wall, maybe just a little notch, or have a panel mount connector on top of the box. Probably not though, because that's close to where the hood closes, right down here. I have to pass it through the sidewall. I've got the bus bar serially connected here. Same thing with this one. This positive will run to the rear of the car to the other pack. I have to figure out how I'm going to get a cable through the wall here, or if I'm just going to pass a bus bar through the wall with some grommet around to prevent it from conducting into the walls here. A concern of mine is next I run a steel strap all the way here to cinch the module down. And this is already sitting pretty high. I might switch this to a button head just to get 100 thou more clearance instead of this. To solve that clearance issue, on the left I got some button heads. You can see how much lower the profile is and how much more clearance I'll have to those steel straps. Put down a third layer of mica. This time I don't need to notch it because the cable's already run that way fairly easily. And a third layer of yoga mat for the top. And you can see I'm already very close, probably interfering with the top of the box. I'll test that next. But next, the straps running across should compress this down a bit. So I'll see how much space I have. Might end up needing to delete the bottom yoga mat layer. Or the top yoga mat layer, we'll see. Here's the horizontal strap with the flathead to go into the PEM stud, PEM nut here. Same thing over there. I put heat shrink on the last few inches because again I'll be passing some sort of bus bar right along there and I don't want to conduct through here. Same thing over here, but I guess there's less of a worry. One thing to note is I'm not setting up the coolant passages right now. That'll be a different stage in the build if I decide I need it. But I do have space. I'm mocking this as if the main positive and negative terminals are back in here, because I don't really need to get in at anything here. If I do want to put the coolant later and this is in the front, I can take the top and front panel off and have a ton of access to work here. So that's why I did it this way. And so this was my worry. The more I tighten down the gap here and over there, the more the bar lifts here in the middle. So maybe I'll have to run a spacer in between these because I am bearing down on the corner here. I'm hoping this is good enough to hold the modules down. Otherwise, I will have to run some horizontal straps too. And since I don't have any sidewall thing to put the straps into, I would likely have to run a strap, then run it out the side of the box at the bottom here. You can see how much it's bowing here, definitely over the top of the box. And I will probably have to delete one, if not two, yoga mats. And I'm going to make another one of these to have the matching pair. I'll probably make 2 more so I can put heat shrink over this also, because it is a little close to the cell bus bars. I wouldn't want it to chew through the plastic over time and contact and short through here. So I'll make more of those. Here on the corners, it is a little close to the bracket here. And there are bus bars on the bottom there. But I don't need to worry about contact happening and shorting between here, because there's a hard plastic layer here right on the corner that wraps around. This shows it better. So the bus bar for this cell group ends right here. And then this is all hard plastic. You can see that, all this yellow stuff. So the corner, if it wears through, will contact plastic. And then my mica sheet comes out all the way to here for insulation between the bus bar and the bottom plate. So this is the configuration I'm going with. 1 sheet of mica, a sheet of mica, single yoga mat, and a sheet of mica. That has these where the straps are just starting to bow a little, and they're holding down, but they're not lifting up too much. And I still have some cushion between the 2 modules. I still have clearance to fit on the top cover too, without it contacting the straps. Another thing I realized is these different modules have, you can see this coolant is much further out than this one. So my idea of having this bar snake behind the coolant isn't going to work. I flipped this bar so that it's up against the wall over here, and so I can drop them in vertically. That'll result in a little tougher access because I can't just tighten on hose clamps this way. I'll have to come in at an angle if I ever add the coolant. But I will deal with that when I get there. So here's the box mounted under the hood with the 2 flatheads here and the 2 flatheads back here. So you can see how tight my clearances are to the side of this flare on either side. And the box would be loaded in with these straps already, and I would put the modules and the layers in as I just showed. After all the modules are installed, I can put on the top plate and the front plate. Now this is just to prove that there is clearance and I can close the hood. There, it's fully closed. From the side view here, it looks like this is going to hit the hood because it's up above the side rail. But that's where I was talking about earlier. The hood has a crown to it, so there's more clearance in the middle and it barely clears. Another challenge is that I wanted to run this out flat, and it barely works because there's just barely clearance from the front rail to the flat panel. Barely clears the bell housing here. So all these things are stacking up together and it barely fits. I'm super happy.